Bismillah ar-Rahman ar-Rahim. And we'll finish this one. Now we'll move to the next slide. I think this group of questions, they are the questions of the last year. So let me check the first one. It says the value of C for which has a removable discontinuity. I mean, the last year when we started using this new book. Removable discontinuity means what? The limit. For sure, we're talking about 2 because these functions are continuous. We have no problem, just the junction point. So the limit as goes to 2, f of x should exist, but either f at 2 is undefined or the or it's not equal to f at 2. Since s of 2 is defined, I have at 2 I have 60. So, but does not equal f of 2 to have a removable discontinuity. Okay, if it's equal to f of 2, then the function is continuous. Okay, so let us check the limit. This limit exists if right equal left. So check right, that should be equal to left, as goes to 2 from left. And see how many c's we'll get. Right, I am there, so that will be 2c plus 8. Left, I am here, that will be c square plus 4c. So just an equation, c squared, take to this other side, plus 2c minus 8 equals 0. Factor it. So it will be c plus 4 times c minus 2 equals 0. So c equal 2 or c equal minus 4. Okay. Now I need to check for c equal 2. What is the limit as goes to c as x goes to 2 of the function if c equal 2. Then it goes to 2, it's either 2c plus 8 or c squared plus 2, 4. There should be the same at these two values. So at 2, I have what? 2 times 2, 12, which is the same here. So it's 12. Now also check if at 2. Will c equal 2. If at 2, here we know that is if at 2 equals 6c. So that will be 12. That means what? When c equal 2, f is continuous at x equal 2. Now I will check when c equal minus 4. What's the limit? As goes to minus 4 for this function. So I'll substitute 4 here because this is represent the limit. It's minus 4. Minus 4, it will be 0. Here I have what? 16 minus 16, which is 0. It should be the same. F of 2, if c equal minus 4, 2, 6 times minus 4, it will be minus 24. So they are not equal. Means what? Means f has a removable discontinuity at x equal 2. And that happens when c equal minus 4. So this is my answer. The number of discontinuities for this function. we notice first, if you look at this function, the problem come from where? Come from the Grace integer function. I know that the Grace integer function of x is discontinuous since the limit right from left not equal to each other. Fx is an integer. Fx is an integer. Okay, look at this interval. If you lose the interval, this is minus 5 over 2. This is 5 over 2. How many integers we have? We have minus 2, minus 1, 0, 1, 2. So we have 5 integers. We have 5 integers. But look at this function. This function is not only Grace integer of x times x. Okay. So this limit is discontinuous. Why? Because the limit, as this goes to, let me say, n from right, where n is an integer, does not equal limit as goes to n from left for this function. But I'm not only checking the limit from now to check the limit as x goes to n from right for x greater than of x, I want to check equal to this to be continuous. And then I'll check also f at n. So this is, I'm not checking only this, multiplying it by x. If I take 1, if I take x equal 1 as an example, I know the limit of this. I know what will be the limit for x equal 1. The limit as it goes to 1 from right is 1, and the limit as it goes to 1 from left is 0. So here what will happen? This will be 1 from right for x equal 1. And this is times 1, x equal 1 here. And this is 0 times 1. So for sure they're not equal to each other. And the same thing with 2, with minus 1, with minus 2. At 0, since I'm multiplying by 0, 0 times any value, it will be 0. So when I have x equals 0, here is the catch. But because I'm multiplying it by x, at 0, what will be the limit? As it goes to 0 from right, it will be 0. From left, it will be minus 1. So here from right, this will be 0, and this will be minus 1. This will be minus 1 as the greatest integer. However, I'm multiplying it by x, so I'm multiplying it by 0. And the same thing here. So they are equal to each other. Because of this x, multiplying it by 0, for sure, that effect will be dissolved. And also, f at 0, for sure it's 0. So the function is continuous at x equals 0. Here it's continuous. So how many points we have? 1, 2, 3, 4. So the number of discontinuities is 4. I hope it's clear. This function, he said, is continuous. Find a squared plus b squared. First, the way they wrote the function, you need to resolve this. What's the meaning of absolute value of x less than 1? Means x between, no equality, x between minus 1 and 1. What's the meaning of this? Means x less than minus 1 or x greater than 1. Or x greater than 1. Okay, so I rewrite the function first, then everything will go smoothly, inshallah. I have what? It will be bx. Here I have the equality. If x less than minus 1, a plus tan by x over 4. If x between minus 1 and 1, and bx again, if x greater than or equal to 1. Now I will work, I will check the continuity for this function. This is continuous. I have problems. This one also is okay. Yeah, tan has some problems, but in this interval, I think they are okay. So this one will be okay too. So I need to check what? These junction points. So at x equal minus 1, for this function to be continuous, limit x goes to minus 1 from right, equal limit x goes to minus 1 from left, equal f at minus 1. So that implies what? Minus 1 from right. I am here. Just substitute. You have a plus tan minus pi over 4, which is minus 1. Let me write it here. A minus 1. X goes to 1 from left. I am on this side. That will be minus p. This f of minus 1, it will be the same as this one, so no need to write it. Equal to a minus 1 if you write it. It will not give you anything. This is why I'm getting one equation, a plus b equal 1. This is my first equation. Now we'll do the same as it goes to 1. For x equal 1, I need to check from right. equal limit is goes to 1 from left equal f at 1. From right, I am there, so that it will be. From left, I am here, so that will be a plus 1. So we have what? A minus b equal minus 1. Two equations, two unknowns, just solve them. They are easy ones. Cancelled, so 2a equals 0. That means a equals 0. That means b equal 1. Okay, just substitute here. You get b equal 1. So that means a squared will be 0 squared plus 1 squared, which is 1. So this is the following statement. Is it always true? Yeah, this one is about the formal definition, which is not part of this course. Here, if f and g are functions that g is continuous at c, then this limit, this one is continuous. No, I need the limit. I need two things. For f of g of x to be continuous, I need this also. I need actually f. I need it to be, f should be continuous. So this statement is wrong. This is not with the continuity. This is related to us. If f and g are functions so that the limit is equal to L, f of g of x equal f of L, no. The same thing. I need f to be continuous. I need f to be continuous. If f is continuous, that cannot be open. It should be, this is the intermediate value theorem. He's writing the intermediate value theorem. So this should be closed, not open. So this is wrong. If it's a function, no, it's not any function. F should be continuous. Should be continuous. It's correct now. This is the intermediate value theorem. These two for the intermediate value theorem. So this is wrong because he missed the continuity. So the only answer is A, which is not part of our course, but the rest is okay. If the constant A will make the function this continuous, خلاص, that means I need the limit. I just goes to 1 from right, equal the limit is goes to 1 from left, is equal f at 1. So that implies what? A e to the power 1, e to the power 0, which is 1, a plus 3. No, this is from left. From right, substitute here, it will be tan inverse of 0, which is 0 plus 2. So I have 2 equal yeah, 2 equal a plus 3. So that means a is equal what? Minus 1. So a squared plus a will be what? 1 minus 1, which is 0, which is this. Okay. Next one, the domain of this function. Just checking the domain. When this function will have a problem, if the greatest integer of x minus x is equal to 0. We have that should be not equal to 0. So we don't have something over 0. So that will lead us to what? When this is true. When this is, yeah, I need to avoid this. Where I know that the greatest integer f x is an integer, and this is, it will be the greatest integer will be the same as x. I mean, when the greatest integer of x equal x, that only if x is an integer. So that will lead us to what? We need to say, no, the domain of this function is all real numbers except the integers. Because if x is an integer, I have, this one will be 0. So this is the right answer. But no, just the integers. Yeah, I think this is the similar to that, to the other one. Similar to this one. Yeah, it happens sometimes. So I know a equal minus 1. So this is the answer. This function has a non-removable discontinuity at x equal what? At x equal, yeah, where is the problem? The problem is with this greatest integer function, where the limit this goes to n from the greatest from right, not equal the limit as this goes to n from left. And that is happening only if n is an integer. If n is an integer. That will lead us to what? As I said, this is true, or this is they are not the same if n is an integer. That will lead us. I need to avoid the integers, because the integer for sure it will make the limit will not they will not be the same. This 4 will not make any effect because it's outside the greatest integer. This is the same thing. The other things will not make any effect. So the effect is only with the greatest integer. So that will lead us, this has an unremovable discontinuity limit. It does not exist because right not equal to left. If x is an integer. If you look at the answers, these are not integers. So this is the only integer. So this is the point behind this question. Okay.